once again. As you can see, the door has no knob, but it opens on one side. Anyways, for today, we have an hour or so until to go back our sort of rented car. You know, the one that I got kidnapped in. Basically, it's white almost. It's gray actually, but anyways. Deception is a tool to encourage attention to occur. Let's just position this a little nicely done. Nicely done. Just like so. Very nice. So, today we are studying. I'm trying to keep a streak for this. If it's not obvious enough. Right? Alright, everybody. So far, we have assumed that all variables in our linear regression model are quantitative. That makes sense, right? And I have said this yesterday before I was, distracted, that quantitative values are like data points in a regression model. And that is what we have been assuming so far for all our variables, right? However, in practice, some of them are categorical. Now, what is an example of a categorical value versus a quantitative value, like the data points that we've mentioned already? So categorical values are stuff that cannot be measured, but they do have categories in which, for example, we have like a Nashville hot chicken burger, right, from Dave's, right, that yummy one. And there are categories in which you have the mild, the medium, the hot, and then the extra hot levels of heat for that Nashville hot chicken burger, right? So this is an example of a qualitative or categorical value predictor. So in credit card data sets, like in the one that we have in our R program called the ISLR2 package, a dataset containing information on 400 customers. Now, for a credit card data set, it could, come off as quantitative, but in this case, I think there are categorical examples for the credit card data set here. So here there are 4 categorical variables: owning a house, being a student, marital status, and the region, east, west, or south. So that's categorical, right? You can't measure whether someone owns a house. You can't say, oh, I guess you can say this person owns 4 houses, but in this case, it's categorical because you could say yes or no, but you can't measure how much yes, how much no. Like you could say yes, this person has a house. Yes, this person has a house, but one could have 2, one could have 1, right? You can't really answer that in a quantitative way. So this is an example of a categorical variable. So not just that, but being a student or being married or whatever region you're in, right? Because these are yes or no questions, but also regional options for in this categorical value. All right, so next we have predictors with only 2 levels. Now this is the one that I already mentioned though, like the yes or no questions, right? The one that was like east, west, south. I think that has more than 2 levels, of course, because there's northwest, east, south. So we wish to investigate differences in credit card balance between those who own a house and those who don't, ignoring all the other variables such as whether they're student or marital status northwest, east, south, south, etc. So here, own only has two levels, no and yes, right? So natural idea is to separate the data in two parts, yes and no. One part is with people who own a house, and another part is people who do not own a house. Very, straightforward, like everything we have mentioned, right? So discussion, why might this not be a good idea? There are three reasons listed here. So reason number one, with more categorical variables, each data subset might not be large enough. So we're gonna get more into that, but from what I could make of this while reading it, we know that with more categorical variables, each data subset might not be large enough. So what does that mean? Like with more categorical variables, like is he a student? Is he married? Like that. Each data subset, like the data subset. I don't even know what that means. I don't even know what data subset means, but we're gonna go over that. So we will be fitting a model with less training data. Okay? Training data, making the results less accurate. So fitting a model with less training data to make it less accurate. That's not good, right? We want accurate results. So that's the reason why it's not a good idea. And welcome one viewer. Please stay. Thank you. The interaction term effect will be ignored. So what does the interactive term effect mean? It means interaction term effect. It means like whether someone's married, has a house, what is the interaction between those two things? Categorical values. It could be ignored. It could not be related. So here, own has only two levels, whether you have one or whether you don't. So instead, we can create an indicator, right, or a dummy variable that takes on two possible numerical values, 0 or 1. So that's pretty straightforward, right? 0 means no, 1 means yes. For example, xi is either 1 if the ith person owns a house, or 0 if the ith person does not own a house. Like I just mentioned, right? So now the underlying model becomes yi equals beta 0 plus beta 1 xi plus epsilon I. Or yi equals beta 0 plus beta 1 plus epsilon I if the ith person owns a house. And beta 0 plus epsilon I if the ith person does not own a house. Why? Because beta I here is attached to xi, right? But if xi is 1, then you don't put 1 here, right? 1 is the imaginary multiple of every term. But if xi were to be 0, then this entire term would be gone, right? Because it's attached to b1. b1 times 0 is 0, so you don't even need to put that in there. bi times 1 is just bi. So if the ith person owns a house, it's this model here, and this if they do not. So that's pretty straightforward, right? Because this is now your yi variable. bo plus b1, beta 1 plus b0, beta 0 plus beta 1. So regression reg equals lm balance delta own comma data equals credit. This is the R command on the R code. So it's not really that important because we don't use R code for the exam, right? But we need to know what that line of code even does. So beta 0 hat. So the hat part is important, right? Because hat means it's an estimation. So beta 0 hat means, and this is the value of beta 0 hat, if you do not own a house, the average credit card balance is 509.80. So the hat, like I said, is an average or like an estimate. And beta 1 hat means, on average, people who do own, yeah, who own a house has. No, I don't know. I'm just here to study. Like, I was letting them sleep. Yeah, yeah, yeah.
Okay, cool. But whenever you have time, you don't have to do it now.
I have time right now, but I don't have the card for that room.
Oh, is Fatima and Aisha not here?
No, it's just me. I was studying.
Oh, okay. So if you go to that room, because they want to come in here.
Oh, okay.